Hello, could you confirm once please that you can see me and you can hear me as well as you can see these slides? Just one confirmation. Hello, could you please confirm once that you can see me, you can hear me as well as you can see these slides?
Yes.
Okay. Thank you. So, very good afternoon, everyone. My name is Ambuj. I am a research scholar at Agricultural and Food Engineering Department from IIT Kharagpur, and I'll be taking your live interactive session for the course Computer Vision. This course is taught by Professor Jayant Mukhopadhyay from IIT Kharagpur. And what we will be doing, we will be solving some of the objective questions based on the previous week's content in front of you all. Okay. So my kind request is please take a notebook and paper, notebook and pen, and please jot down at least the points which I will just show in front of you. Okay. Try to solve also. If you are able to solve, then please tell me the answer using the chat box. Okay. Otherwise, just see the approach which I am following so that the same approach you can follow in the examination and you can pass this course with flying colors. That is what my intent is. Okay. So let us start the session. And in the later part of the session is divided into two parts. In the later part of the session, I will be sharing with you some of the Google Colab notebooks which I have prepared. Okay, so that you would be able to see that how these concepts are done practically, these concepts how they are solved practically. Okay, that also I'll try to demonstrate. Okay, so let us begin. Okay, so the very first question for the present session is this one: which of the following statements are true for an ANN, artificial neural network, in short is known as ANN. This is very popular. Okay, ANN, artificial neural network, or your ANN. Which of the following statements regarding this is true for an ANN? Okay, a single neuron with two out inputs and the signum activation function can implement an AND gate. A single neuron with two inputs and signum activation function can implement an XOR gate. Okay, a single neuron with multiple inputs and signum activation function acts as a linear discriminator in multidimensional feature space for two linearly separate classes, or a single neuron with multiple inputs and the sigmoid activation function computes posterior of a class for a two class classification problem in a multidimensional feature space. Please provide your opinions if you are able to follow. Then after a minute, I'll tell you what is the correct option and we'll discuss. Okay. Yes. Please try to provide your opinions. Okay. Let us discuss the things. Okay. The correct options will be A, C, and D. Okay. Only the option B is not correct. Rest all of the options are correct. Why? See, the first statement was this one: a single neuron with two inputs and the signum activation function can implement an AND gate. Yes, it is true. Why it is true? Because the AND gate is linearly separable. Its positive output contains when both inputs are 1, which lie on one side of the line in 2D input space, and a neuron with signum activation can place that decision boundary to accept only the 1 point. Okay, so yes, the implementation is possible. The second statement was a single neuron with two inputs and the signum activation function can implement an XOR gate. No, it is not true. XOR outputs 1 for 0 1, 1 and 1 0, but 0 for 0 0 and 1 1. Okay, so this particular implementation is not possible because these positive examples are not separable from negatives by the single straight line which is there in the plane. Okay, And your C option was a single neuron with multiple inputs and signum activation function acts as a linear discriminator in multidimensional feature space for two linearly separable classes. Yes, this statement is true because signum function computes the output as given here. Okay, as it has been mentioned here, this is the exact hyperplane decision boundary. Okay, it will directly differentiate your both the planes into two half spaces. Okay, so that is why the thing is there. And if two classes are linearly separable, okay, then one such hyperplane will suffice for perfect classification. Okay, this is the thing, this you need to see. Okay, now moving forward. Okay, D option is a single neuron with multiple inputs and the sigmoid activation function computes posterior of a class for two class classification problem with problem in a multi-dimensional feature space. Yes, this statement is also true. Why? Because you are modeling the in logistic regression, the follow the model which is followed is like this. Okay, either in probabilistic mode you have to give the values. Okay, so under the mild assumptions equal class priors log odds linear inputs. Okay, exactly the posterior probability of the positive class will be formulated, and a single sigmoid neuron can all is commonly interpreted as the outputting the posterior. Okay, so this statement is 100% true. Next, moving forward, consider the following table. The table shows the points on x-axis and the corresponding class, and a point in class classification has been given here. Okay, now you have to introduce two new points on x-axis, 3.7 and 4.2. Okay, compute knn at k equal to 3 to determine their class. Okay, so these type of questions are very important from examination point of view. Okay, these are very frequently asked, so please be aware with it. Okay, yes, do try to solve. Okay, do just try to solve this particular problem. At least take a notebook, pen and paper. Okay, try to jot down what are the problem that has been given. Okay, now if you see here, okay, you have to determine the classes of the new points 3.7 and 4.2 using the KNN or K nearest neighbor algorithm. K has been given here as 3. Okay, this already has been given here. Okay, now if you try to see here, you have to analyze the given data and then compute the distance to find the three nearest neighbors. Okay, then the class which is then assigned based on the majority class among these neighbors would be the desired output. Okay, so 2.5 that belongs to class 1, 3.5 belongs to class 2, 4.0 belongs to class 1, 5.0 belongs to class 2, 5.5 belongs to class 2. You need to classify the points 3.7 and 4.2 using your KNN with k equal to 3. Okay. So KNN algorithm, it calculates the distances. Okay. For each new point, compute the Euclidean distance to all given points. Since the points are on x-axis in one dimensional, okay, the distance between a point x and a given data point xi will be simply x minus xi. Then you have to identify the k nearest neighbors, selecting k equal to 3 points to the smallest distances. Then you have to assign the class that appears most frequently among the k nearest neighbors. Okay. So first of all, you have to classify the first point, that is 3.7. So now you try to calculate the absolute distances of 3.7 to each data point. Okay. To 2.5, then 3.5, then 4.0, then 5.0, then 5.5. Okay. Similarly, I have calculated the distances to each of the point. Okay. Then what are the all the distances which I have got are 1.2, 0.2, 0.3, 1.3 and 1.8. Then if you will sort the distances in ascending order, you will get as 0.2, 0.3 and 1.2. These are the sorted distances. Then the three nearest neighbors you will get as x equal to 3.5, x equal to 4.0 and x equal to 2.5, and classes belong to 2, 1, 1. Okay. So the majority vote with two neighbors are class 1, one is class 2. So 3.7 is assigned directly as class 1. Okay. Now classifying the second point, which is 4.2, to compute, first of all, you have to compute the absolute distances from 4.2 to each of the data point. Okay. So 4.2 minus 2.5, 4.2 minus 3.5, similar procedure which we have done for point number 1, we are doing it for point number 2 also. Okay. Then 4.2 minus 4.0, then 4.2 minus 5.0, then 4.2 minus 5.5. Okay. All the absolute distances you try to just calculate. Okay. Then you try to sort the distances in ascending order. Okay. You will get a 0.2, 0.7, 0.8. Okay. These are your three nearest neighbors are 4.0, 3.5 and 5.0. So classes are 1, 2, 2. So majority will go with class 2. Okay. So the point 4.2 will be assigned as class 2. Okay. Then your options are 3.7 belongs to class 1, okay, and 4.2 belongs to class 2. So this is directly matching with, I think, your option number B. Okay. So option number B is directly the correct option. Okay. So if a visualization you want to create, then on the right hand side I have plotted the graphs also. Okay, for each and every point for class, whether it belongs to class 1, whether it belongs to class 2. Okay, or any new class is assigned, that we have just displayed in this particular graph. Okay, visualization purpose you can see it. Okay, moving forward, next question, question number 3. Assume you have five types of objects with three attributes, each as shown in the table. Consider the object A and object C as the initial centroids. Okay, object A and object C are the initial centroids, and the classification has been given attribute 1, attribute 2, attribute 3. Then what will be the elements in each clusters after first iteration that you have to define? Okay, simple question is there. Okay, do try to solve it. Take few minutes time, at least try to jot down the question along with the table. Okay, then we'll try to discuss how it will be solved. Okay. Yes. Now, if you try to see here, okay, K means, as you already know, it is an unsupervised algorithm for clustering, okay, or grouping data points into K clusters so that within cluster variance is minimized, okay, and between cluster variance is maximized. That is the basic concept regarding your K-means clustering, okay. So now, how do we do it? We do this by representing each cluster J with a centroid mu J, okay, the center of all points assigned to that particular cluster, okay. So how the particular algorithm is performed, that we will just try to see here in this particular outline. Okay. First of all, you have to initialize the k initial centroids, which are mu1, mu2, mu2, mu3 till up to so on up to mu k. Okay. Often these are drawn from data points. Okay, as it is there in your question number A and question number C. Okay. Then your assignment step is there for each data point xi. You have to compute its distance to every centroid mu j. Then assign xi to the cluster whose centroid is nearest. Okay. Then in third step, you will update the step. Okay. For each cluster j, you will recompute the centroid by taking mean of all the points currently assigned to that particular cluster. Okay. Mu j, that would be equal to 1 upon Cj mod, okay, and summation xi from xi to Cj. Simple mean is there, okay. Then repeat the assignment and update the steps until assignments are no longer changed or some convergence criterion is met. Till and then till to that particular point you have to continue, okay. Then you have to compute the distance metric, okay. K means will almost always give you the Euclidean distance. Okay. For points in your d-dimensional space, the distance x comma mu would be given by under root, okay, whole under root and then summation k equal to 1 to d xk minus mu k and whole square of that. Okay. In our example, okay, d equal to 3. So for all the points x equal to x1, x2, x3, centroids mu equal to mu1, mu2, mu3, okay, you will calculate the distances x1 minus mu1 whole square plus x2 minus mu2 whole square plus x3 minus mu3 whole square, okay, and after that you will take the under root. So for the first iteration, okay, mu1 is point A, which is given by 111. Mu2 is point number C, which is given by 532. Now, coordinates, okay, distances of each object to both centroids you have to compute, then you have to assign. Okay. From object number A, it is 111. Object number B, it is 212. Object number C is 532. Object number D is 440. And E is 313. Okay. That is the thing already given in the question. Okay. Now you have to compute distances D1 and D2. Then compare D1 and D2 and assign X to whichever mu j is closer. Okay. Cluster 1 close to A is ABE. Cluster 2 which is close to C is CD. Okay. Then you will recompute the centroids, new mu's, mu1s, new mu2, then reassign, then repeat this thing. Okay. Why K means find the spherical clusters? Why? Because it uses Euclidean distance and means K means naturally positioning partitions. Okay, naturally partitioning the data into roughly spherical clusters of similar size. And it optimizes a global objective, but it often gets stuck into a local minimum. That is the particular disadvantage of this clustering pattern. Okay. Then key takeaways are these many. K is the number of clusters, k equal to 2, and each iteration alternates between assigning points to nearest centroids and updating centroids to the means of the assigned points. And after each assignment, you will exactly get the choice as A. Okay. So this was your question number 3. Okay. Do repeat it. Okay. Otherwise, directly, if this method is not suitable for you, directly you can use this particular method also. From each cluster, you try to calculate the distances, okay, of centroids. Okay. Directly you try to compute, and after computation, you will get two clusters as A, B, E, and C, D. Okay. So both the approaches are there, whichever suits to you. you can follow. Okay. Now you try to solve this particular question. The output of a neural network is 24715, and what is the softmax probability for 7? And you have to answer it to the four places of decimal. These questions are very, very frequent in objective type of questions like GATE, objective type of examinations like GATE. Okay. So these questions are very, very common in GATE examination. Okay. So you can always try to follow this type of questions for your competitive examinations also. Okay. The output of a neural network is 24715. Find the softmax probability for 7. Take 2 minutes time. It is very easy. At least compute and tell me the answer. Then we will try to discuss. Yes. Let us see this particular question. Okay. Softmax probability for a score of 7 will be nothing but exponential 7 divided by summation of all the exponentials from 24715, because the transfer function is exponential. That is why it has been written like this. Okay, so it would be exponential 7 divided by exponential 2 plus exponential 4 plus exponential 7 plus exponential 1 plus exponential 5. Okay, e to the power z. That is what we are trying to follow here. Okay, so sum of all exponentials, if you will try to compute all the powers, okay, from 7.3, it will be 7.3, 5.4, 54, then 1096, 2.7183, then 148.4132. That would be coming as 1309.7520. And softmax probability would be nothing but e raised to power 7 divided by this particular summation which we have got. E raised to power 7 value already we have computed, and now we will get it to 4 decimal places at 0.8373. But in gate examination, the twist is this, that when you will be computing the exponential, it is different from your scientific calculator. It is an it is a online virtual calculator. I'll just try to show you how it is done in the your virtual calculator. Please give me a minute. I'll open the calculator, then I'll show you. Okay. So if you see here, okay, question demands us to calculate exponentials from 2 to 4, 7, 1, 5, and you have to divide it by exponential 7. So in gate examination, this is very, very important. You just have to understand that how this particular scientific calculator is used. Okay, this is very, very important for you to just understand. So if I have to compute this particular value, what methodology I will follow, you try to see here. First of all, I will write 7. Then I will write it as either e to the power x, okay, or I will use this exp. Okay, so let me see here. Yes, exponential 7 I am getting 1096. Exact value I am getting. Okay, now you try to see here. I'll close the bracket, then I'll divide it, then I'll resume the bracket. After resuming, I'll type 2 first, then I'll use this e to the power x. Okay, then I'll use plus here. Then what is my second numeral? 4. 4. Then exponential of that. This is very different from your scientific calculator which you use on the daily basis. Okay. So that is why I am repeating here itself. Okay. How you have to compute it in the gate examination. Please see very carefully how I am doing it. In the similar way, you can do it in the gate examination. Sorry. 0.83728 or 0.8373. I have calculated this particular value in front of you. You can see here why it is different, because first of all you have to type here the numeral. You have to type 7 here, then go to e to the power x. It will directly compute power e to the power x. Then you press equal to, you will get the value. So this is the difference. Directly you have to incorporate, because since it is a 1 mark question, you know the formula and you know everything. And then directly you have to incorporate these values in the calculator. Okay, don't have to apply any logic, or you have to see that how things are going. Okay, just have to apply the logic, apply the values in the calculator, and rest everything will be taken care. Okay, just the thing is, you have to be very careful. Sometimes you are not able to see the values. In those cases, for example, till the power e to the power 1, I am not able to see afterwards, but I am remembering it, what I have typed, what value I have typed, what sequence I have typed, and then I am putting the brackets accordingly. So this will come with the practice. Many of the students who are appearing for GATE may just try to see this particular thing. Okay, this would be very, very helpful for you in your examination. Okay, so let me go back to the slides. Okay, let me just reshare the slides. Okay, yeah, so we were here. Okay, so I just tried to show you how exactly this values in a single line you can calculate using the scientific calculator which is there for your gate examination. Okay, next you try to see some of the concepts. Softmax is a fundamental function which is there in machine learning, especially in multi-class classification with neural networks. It takes a vector of arbitrarily real valued scores and it turns them into probability distribution over the class. Step by step breakdown is like this. Given the scores z equal to z1, z2 till zk, the softmax for class J is softmax zg equal to exponential zg z- divided by sum of the all the exponentials zi's. Okay. exp is the exponential function ensuring outputs are positive. Denominator summation of exponential zi normalizes the vector. All the softmax outputs sum to 1. Okay, so each softmax zg, okay, which belongs to 0 to 1, so that they can be interpreted as probabilities. Okay. Why the exponentials? Because the amplification of differences is there. Exponentials exaggerate the differences among the scores. A score even slightly higher than the rest becomes exponentially more influential in the numerator. That is why it is exponential. The smooth differentiable is there. Exponential is infinitely differentiable, which is crucial for your gradient based learning. Okay. Then interpretation, if Zj is much larger than the other Zi's, the exponential Zj dominates the sum. That is, softmax Zj is approximately equal to 1. Others are nearly 0. Okay. If all Zi's are equal, then each softmax Zi is 1 upon k. A uniform distribution is there. The softmax thus focuses probability mass on the highest logits. Okay. They use direct use age is there in the neural networks, the logits. Okay. The network's final layer typically outputs a real vector z of length equal to the number of classes. Okay. For your softmax layer, applying softmax converts the z to probabilities y cap. Okay. And your cross entropy loss is there if you will be using one hot true label encoder. Okay. Then the your cross entropy loss has been defined as a negative of summation j equal to 1 to k yi log yj. Okay. This will minimize the minimizing this encourages the network is assigned to a high logit. Okay. The high softmax probability is there to the 2 class. Okay. Then numerical stability, if you want to see here, then you have to compute the exponentials, which can largely overflow for large ZJs. Okay. Standard trick is there to maximize the logit before exponentiating is just like this. Okay. Just deduct a standard M, which is the maximum ZIs. Okay. From all the values. This you can try for numerical stability. Okay. Then gradient for back propagation. For back propagation, you just have to see the derivative of the softmax cross entropy loss. Okay, it has to be specially clean. Del L over del Zj equal to Yj cap minus Yj. Okay, error signal is predicted probability minus true indicator, which is the simple form which makes the implementation efficient. Okay. Then if you want to go for temperature scaling, okay, sometimes a temperature T greater than 0 is introduced. Okay. Softmax Zj, T is exponential Zj over T divided by summations of all the exponential Zi over T. High T will soften the distribution towards uniform and low T will sharpen it, making the highest logit dominate more. Okay. So temperature tuning is used in model distillation and your calibration. Okay. In summary, your softmax turns arbitrarily real scores into a valid probability distribution over k classes, uses exponential for smooth differentiable scaling, okay, and numerically stabilized by subtracting the max score, okay, and paired with cross entropy loss, it yields simple gradients for learning. Okay, this is the thing. This is the summary. Then moving forward to question number 5, assume you want to cluster 7 observations into 3 clusters using k-means clustering algorithm. After first iteration, uh, clusters C1, C2, C3 has the following observations. C1 has 224466, C2 has 0440, C3 has 5599. What will be the cluster centroids if you want to proceed for second iteration? Okay, so the cluster centroids you just want to see here. Okay, try to see. Yes, if you try to see here, okay, answer would be this first option only. Okay. So role of centroid update. Okay, after assigning each observation to its nearest cluster, K-means will try to recompute each cluster centroid. Already I have explained to you. To the mean of the points currently assigned to that cluster. This is the update step. Algorithm will alternate the assignment, okay, and update until the assignments stabilize. So compute the mean in the multidimensional space for a clustering C containing endpoints x1, x2 till up to and so on xn in relation R D. Okay. New centroid mu would be mu equal to 1 upon n summation of all the xi's. Concretely, each coordinate of mu is the arithmetic mean of the corresponding coordinates of the cluster points. Okay. So applying to your particular cluster, okay. Cluster 1 is having the points 2, comma 2, 4, comma 4, 6, comma 6. Okay. All the x coordinate sum is 12. All the y coordinate sum is 12. Number of points is 3. So centroid is 4, comma 4. 12 by 3, 12 by 3. Cluster 2 is having these 2 points 0, comma 4 and 4, comma 0. So sum of all the x's is 0 plus 4, that is 4. 4 plus 0 is 4. N is 2, so 4 by 2 and 4 by 2, that is 2, comma 2. And cluster 3 is having points 5, comma 5 and 9, comma 9, which is sum of all the x's 5 plus 9. Okay. And y sum is 5 plus 9 also. So 14 by 2, then 14 by 2 is 7, comma 7. Okay. Why mean is there? Okay, because it will minimize the within the cluster distance, cluster variance. Okay. Arithmetic mean is the point that minimizes the sum of squared Euclidean distances to all points in the cluster. For smooth updates also, taking the mean yields continuous shifts of the centroids aiding in convergence. Okay. Next step, you reassign each of the 7 observations to the nearest of the new centroids 4, comma 4 and 2, comma 2 and 7, comma 7. Then recompute the chord centroids again based on the new assignments. Then repeat until these assignments no longer change. This iterative process drives the k-means toward a optimum where clusters are as cohesive and well separated as possible. Okay. So 4, comma 4, then 2, comma 2 and 7, comma 7 are the option which is there in as option number A. Okay. Next, moving forward, consider the following neural network IX. Okay. It has inputs I's. Okay. Bias is BX. HX is the hidden layer. OX is the output. Okay. If all the activation functions are ReLU, okay, rectified linear unit, then the answer the following question number 6 and question number 7. What would be the input 1, comma 1? Okay. This you try to solve. The weights as well as the inputs have been given to you. Okay. Try to solve. O1 and O2 values you have to just calculate. Okay. Yes. If you try to see here, okay, option would be D. Very simple. Calculation is there. Biases, okay, hidden pre-layer activation. First of all, we'll calculate the output as at the hidden layer. Then after that, the final output. You have been given two hidden units, H1, H2, okay, and three inputs having bias B1 equal to 1, okay. I1 is 1, I2 is 1, and reading of the weights from the diagram, bias B1 to H1 is 0, then B1 to H2 is 0, then I1 input is to H1 is -1, I1 input to H2 is again -1, then I2 to H1 is 0, then I2 to H2 is 1. Okay. Net inputs are Z1, which is you try to multiply and get the values 1 into 0 plus 1 into -1 plus 1 into 0, that would be -1, and Z2 would be 1 into 0 plus 1 into -1 plus 1 into 1, that would be 0. After applying the rectified linear unit or ReLU activation function Z equal to 0, maximum of 0 and Z, it will give you H1 as 0 and H2 as 0. Okay. Then at the next step, each output unit O1, O2 will get the inputs bias B2 equal to 1 plus two hidden activations. Now from your diagram, bias B2 to O1 is 1, then B2 to O2 is 1, H1 to O1 is 0, then H1 to O2 is -1, H2 to O1 is 1, then H2 to O2 is 1. So since H1 is 0, H2 is 0, so you will get U1 as 1 into 1 plus 0 into 0 plus 0 into 1, that is 1. Then U2 as 1 into 1 plus 0 into -1 plus 0 into 1, that is 1. Now again you try to apply the value. Okay, O1 will be maximum of 0 comma 1, O2 is maximum of 0 comma 1, that is 1. So final answer is O1 and O2 is 1 comma 1, which will be corresponding to your option number D. Okay. In short, the calculation has been given here, and in the long route with full explanation I have already shown you. Okay. Now let us solve the next question. Okay. Let us dig a more deep into the explanation. Network structure and notation was like this. Input I1 is 1, I2 is 1. Okay. Hidden layer was having two hidden neurons, H1 and H2. Activation function is maximum 0, comma Z. Okay, two output neurons for O1 and O2. Okay, you have to use the ReLU, and weights already have been given here. Then hidden layer computation is there. After hidden layer computation, output layer computation is there. Okay, and putting all together, you will get O1 and O2 as 1. Okay. Moving forward to the seventh question, what will be the output if sigmoid activation functions are used in the output layer instead of ReLU? Okay, hidden layer is still will be having ReLU. Okay, so if you try to solve this particular problem, okay, O1, O2, you have to compute the only condition which is there is that sigmoid activation function is there. Now ReLU activation function is not there, it is sigmoid. Okay, then you try to compute. Okay. Now, if you see here, okay, first of all, you have to recall that the your ReLU will only forward pass, okay, that with output I1, I2 equal to 1, comma 1. You will get the hidden pre-activations Z1 is -1, Z2 is 0. Hidden activations H1 would be maximum of 0, comma -1, which would be 0. H2 is maximum of 0, comma 0, which is 0. Then output pre-activations would be U1, U2. We have already tried to calculate. Now we have to repeat the same procedure. Okay. Till this step, the process is same. Now you have to use sigmoid at the output layer. Okay. So instead of output layer OK as ReLU UK, we will use OK. Okay. OK as sigma UK, which is 1 upon 1 plus exponential minus e raised to power minus UK. So since both U1, U2 are equal to 1, okay, 1 will be equal to 1 upon 1 plus exponential minus 1. Okay, that is 0.7311. O2 would be 1 upon 1 plus exponential minus 1. That is 0.7311. Okay, then rounding off to the three decimal places, that would be 0.731, 0.731. That is option number B only. Okay. So this is regarding question number 6, question number 7. Please, after the class, my sincere request to you is take a note of it, all the questions which I have discussed, okay, especially question number 6, question number 7, because this is the favorite question of the examiners regarding your neural network training and visualization. Okay. Now you try to see question number 8. Consider a multi-layer feed-forward network that takes a 10D feature vector as input and produces a 2D output vector. The network has one hidden layer with number of neurons as 15. Please note that the input vector is the input to the first hidden layer. What is the dimension of parametric space over which the optimization processes would be carried out to train the network? Okay, this is the question number 8. Okay. If you see here in your feed forward network, every weight and bias is nearly a free parameter. Dimensionality of parametric space is simply the total number of parameters. Okay, that is the thing. So from input to the hidden layer, the hidden layer is having 15 neurons. Each would be receiving all the 10 inputs. So weights from input to hidden layer would be 10 into 15, that is 150, and biases would be 15. From hidden to output layer, weights would be the output is having two neurons, so each would be receiving 15 hidden activations. So weights from hidden to output would be 15 into 2, that is 30. And biases from each output neuron is it having own bias. Okay, so biases in the output would be 2. Okay, so total number of parameters would be 10 into 15. Okay, plus 15 plus 15 into 2 plus 2, that would be 197. So optimization will search over a 197 dimensional parameter space. Okay, this is regarding your question number 8. Total number of parameters would be 197. Very important question. It might come as a numerical question. Okay, numerical objective question. It might come. Okay. Then question number 9. We want to classify whether a special wire is good or not. Then consider the following table of 4 samples. Okay. Table number 3 is there. Okay. Durability, strength, and label. We introduce a new wire with a durability 3, strength is 7. Then which of the following statements are true after computing KNN k equal to 3? Okay. Try to take a note of it. Try to solve. Okay. I'll just join in 2 minutes. Okay. If you see here, okay, true statements are just C and D. It was an MSQ, okay, multiple select question. True statements are option number C and option number D. C 3 comma 7 is a good wire, and the nearest sample to 3 comma 7 is at a distance of 3. Okay, why? See here the detailed explanation. Durability, D has been provided to us, strength has not been provided to us, and the level has been provided to us. And you have to classify a new wire at 3 comma 7 using three nearest neighbors with Euclidean distance. Okay, so compute distances to each sample for a point D comma S. Okay, Euclidean distance to 3 comma 7 is D minus 3 whole square under plus 7 minus S minus 7 whole square under root. Okay, so to calculate the distance from 7 comma 7 to 7 comma 4 to 3 comma 4 to 1 comma 4, you have to just take the under root squares. Okay, and then calculate the values. It would be 4, 5, 3 and 3.606. So three nearest neighbors would be at distance 3, 3.606 and 4. Distance 5 if you will try to just remove, okay. And the three nearest are 3, comma 4, 1, comma 4 and 7, comma 7. Okay. If you will try to cast the majority vote among the these three neighbors, good would be having 2 votes, bad would be having 1 vote. Okay, classifying 3 comma 7 is as good. The statement C is true and A is false. Okay, so the true nearest distance statement is the very closest neighbor is at distance 3. Okay, the point 3 comma 4. So statement D is true and B is false. Okay. So 3 comma 7 is definitely a good wire. Okay, the nearest sample to 3 comma 7 is at a distance 3. Okay. Question number 10 and the last question for the present session. After that, we'll try to discuss some of the Google Colab notebooks. Okay. Calculate the cosine similarity between 7482 and 32151. Okay. Try to solve. Very simple. Cosine similarity, just you have to compute. You have been given two vectors 7, 4, 8, 2, and which is the v vector. W vector has been given as 3, 21, 5, 1. Okay. Cosine similarity is cos theta. Okay. V dot W over modulus V modulus W. Dot product V comma V dot W is 7 into 3 plus 4 into 21 plus 8 into 5 plus 2 into 1. Okay. So it would be 147 norms if you will try to calculate the norms. Okay. That would be under root 133 and under root 476. Okay. Cos theta if you will try to calculate using the formula V dot W divided by norm V norm W. Okay. That if you will try to calculate, it would be 147 divided by 251.75, that is 0.5842. Okay. So closest match is option number A. Okay. That is the final answer 0.5842. That is the exact match, not the closest. It is the exact match. Okay. So this was the 10 different questions which I wanted to discuss. Okay. Regarding the present session. Okay. Now I will just try to share with you some of the Google Colab notebooks. Okay. Just give me a minute. I hope you can save my screen. Okay. So this Google Colab notebook I already have provided. Okay. Already shared with you all. Okay. In the same folder in which you would be seeing my notes, you would be able to see this particular notebook. It is saved as amnist.ipyniv. Okay. So if you try to visualize feed forward neural network, okay, feed forward neural network is a simple type of ANN. Okay, it is follows one direction only. Okay, if you want to include back propagation, it will become a bit more advanced and bit more complex. But the main or the major type of neural network which we just try to follow is your just this one only, this feed forward neural network. Okay, multi-layer feed-forward neural network MLFNN or single-layer feed-forward neural network. Both of the neural networks are very common. Okay, so in our research domain, we try to use this type of neural networks. Okay, for classification problem, not limiting ourselves to classification, for a custom object detection problem, for any type of computer vision problem, we try to incorporate ANNs. Why we try to incorporate ANNs? Because they are very good in when you try to find out the patterns in the data. Okay, they are good in finding out the patterns in the existing data, as well as they are good in finding out the patterns in the data when the pattern does not exist in itself also. So for those particular purposes, your this particular feature is very important of feed forward neural network, multi-layer feed forward neural network, BPN and backpropagation neural network. Okay, all these neural networks are very useful in those particular cases in which the pattern in the data does not exist. Okay, or it exists minimally and you are not able to find out using the conventional machine learning algorithms. Okay, those particular cases it is very important. Okay, so why do we need FFNN? Because simple linear models like logistic regression, they cannot solve the XOR classification problem. Okay, I already showed you in my question number 2 that for your XOR classification problem you have to use a feed forward neural network. Okay, so this one is the truth table for your XR when your both XOR, when your both the inputs 0 0, and both the inputs are 0 0, then output is 0 0 1, then it is 1. Then 1 0 is 1 and 1 1 is 0. Here linear classifiers will fail because it is not linearly separable. A line cannot be drawn which can distinguish between the inputs and outputs and provide you the corresponding result. Okay, so that is why you have to solve it using a feed forward neural network. How we try to do this, you just try to see here, import numpy is np, import tensorflow.keras models, import sequential, then from tensorflow.keras layers import dense. Okay, then XOR dataset directly, I have imported using np.array. Okay, here if you try to see here, if I don't know what is the exact function usage, I'll just try to type in the function, then I'll try to put my cursor here. Okay, then directly I'll jump into what is the standard syntax of that particular function. Okay, so this is an inbuilt feature of your this particular Google Colab platform. Okay, so it is very interactive. So similar type of feature you can always explore yourself also. Okay, just download this particular notebook and try to run all the cells. Right now I am running the same. Okay, I ran and see here I have got results also. It is showing me that it has executed successfully. See here, I hope that you are able to see. Okay, 424, it executed in 0.513 second, and right now the base version is Python 3. Okay, different runtime options are there. Okay, you can explore those. Okay, but Python 3 is the latest one, and if you are using Python 3, then only your current library such as NumPy and Pandas, Matplotlib all will work because they are embedded in the background. If you are using a downgraded version of Python, then you have to use the corresponding downgraded version of those libraries also. Okay. Then you try to build a feed forward neural network. How feed forward neural network is built? See here, model equal to sequential. Okay, sequential. Then see here the function I have able to explore. Okay, model equal to sequential, then you try to fit two dense layers. Okay, each would be having input dimension 2, activation function is relu, and another one is activation function is sigmoid. Hidden layer with 4 neurons and output layer is binary classification. Then model.compile optimizer is Adam. Okay, Adam is a single optimizer which will try to optimize the parameters in your entire search space. Okay, you can do it using different types of optimizers. Okay, you can use grid search cv, you can use any function here. Okay, and loss is binary cross entropy that we try to follow here. Matrix which I am currently following is accuracy. Okay, then here I have formulated history equal to model dot fit x comma y. Okay, from the data, epochs equal to 500. Epochs are the set of generations, number of set of iterations for which the entire neural network will run. And verbose, okay, this verbose is nothing but your what? But your bias. Okay, so that I have put as 0. Print training accuracy on XOR is accuracy and up to 4 decimal places. Okay, as a float. Then what are the predictions? Okay, So training accuracy which I have achieved is 75%. And what are the predictions? 0, 1, 0, 0. That would be the same as compared to your XOR mapping. Okay. So the feed forward neural network will learn your XOR mapping. It provides non-linear activation plus hidden layers, making it more powerful. Okay. Another thing or another real world example is your MNIST digit classification. Okay. MNIST digital digit classification, if you will try to show here. Okay, no problem. If I just try to show here to you. Zip and just one second. MNIST digit classification. This is a very important data set. Okay, very usually used in your MNIST. This particular data set is very important for your practical applications. Okay, if you want to build your projects, this is a data set which consists of handwritten digits. Okay, handwritten digits. Okay, it is uh, just a second. It is just like this. It is a this particular data set from your National Institute of Standards and Technology database. It's your large database of handwritten digits, which is commonly used for training and processing of various image processing algorithms. Okay. Creators you can see here, and what is the entire data set? It is consists of images of the handwritten numerals. Okay. And this was the very first initial data set which was used in computer vision for training of the algorithms. Okay, training of image processing algorithms. The very first data set which was used was this particular one only, which is MNIST data set. Okay, so let us scale up. Okay, try to classify the handwritten digits from 0 to 9 using the MNIST data set. Okay, import TensorFlow. TensorFlow is a particular library, STF, then TensorFlow.keras, TensorFlow.keras utils, okay, models and layers. Then you try to load the data set. Okay, it has been already incorporated. That is why directly I can call here. Okay, then you try to normalize. You try to build the one hot encoding. Okay, or another any other encoding you want to incorporate, you can use. Then see here, I have defined a particular feed forward neural network in front of you. It consists of input layers. Okay, total 28 into 28, that is 784 neurons would be present. Then hidden layers are there. Okay, then another set of hidden layer is there. Then output layer is having 10 number of classes. Okay, after that I am using model.compile. Optimizer is Adam, losses, categorical cross entropy, and matrix is accuracy. After that, I am training model.fit, X train, Y train, epochs is 5, batch size is 32, and validation is split 0.2. Then I am going for the test accuracy. Okay. So for 5 epochs, if I try to see here, I have got the test accuracy is 0.9727. Okay. And data set it has directly obtained from your link. Okay. That has been already incorporated in the Python. So after the class is over, you can download this particular notebook, try to play with these parameters, play with these particular parameters. And after playing with these particular parameters, you will realize that how your output is varying. Okay. Either it is moving in the positive direction, or it is moving in the negative direction. You can try to visualize from here. Okay. Then visualizing the training, nothing new is there. I directly have plotted. Okay. Initially, I have shown you matplotlib is the library. Okay. Import matplotlib.pyplot as PLT. Then history of accuracy as training accuracy and validation accuracy, epochs. Okay. So this particular graph I have obtained. And here you can see here that a very high level of accuracy I am able to achieve. Okay, on this particular data set, which is the MNIST data set. Okay, so try to see here till it has plotted from 0 to 4 means total 5 epochs it has plotted. Okay, so initially the train accuracy which is shown in the blue color line, was very low. Then it increased, then after that increased further, then increased further. Okay, so 0.99 something it is able to achieve. And if you want to see the validation accuracy, okay, validation accuracy, if I try to explain you, if for example this MNIST data set, suppose it is having 100 number of values, okay, so randomly you will try to bifurcate all the data set number of values into three parts. First one is training data, then it is testing data, then after that it is validation data. Okay, training might have 70% of the values, means 70 values. After that, testing might have 20% of the values or 20 values, and validation would be having 10 number of values. This is the standard classification procedure for your data set. Okay, training is that particular data set which you would be directly giving to the model. Okay, for training and for your validation. For training, you would be directly giving it to the model has seen it, and on the basis of that it has formulated some mathematical equations, and it will try to either classify or it will try to do some custom object detection or any computer vision operation on those data sets. After that, there are two different data sets we are left with, which are testing data set and as well as validation data set. Okay, this validation data set is up to you. The testing data set is always from the same data set which is used for training. Okay, it is just left out data set. Okay, sometimes we do 70 to 30, 70 30 classification. Okay, so 70-30 classification, if you will try to do, means 70% of the data you try to use for training, 30% of the data you try to use for testing of the same data set. But the validation data set, you can always keep another data set which the model has never seen or experienced. And on that data set, if your neural network is performing well enough, then definitely your neural network is good enough for going into research field or for any publication. Okay, so this is the standard procedure. Okay, sometimes in research papers you will see that the validation for validation also they have used the same data set. So both the approaches are there, but my sincere advice as well as what is followed majorly in the research community is this particular approach, that we try to keep the validation data set aside. Okay, yes, I'll just answer your query. How to convert polar coordinates and curves into parametric surfaces into a Python code? Is there any built-in package or function, or do we need to create our own formula? Both the approaches are there. Built-in function is also there. Okay. Directly, if you want to calculate, if you want to convert, okay, how to convert polar coordinates and curves into parametric surfaces. Directly, I don't think so. There it is there in the Python, because Python is mostly mathematical. First of all, what you have to try to see here, you try to plot your coordinate system. Okay, try to plot your own coordinate system. Okay, then mathematically you try to convert. Mathematically it is possible, and try to use that same function in your Python code. Okay, so this approach will simplify your task. In GitHub, you can find a lot of libraries which are just doing the same type of function. They've used that particular library. So from there also you can import. Otherwise, my request to you is that be a bit fundamental, because you are moving in research direction. That is why you should be a bit more fundamental. Okay, first of all, you try to convert those particular coordinates. Okay, mathematically, you try to convert. After that, write the function for the same in the Python. Okay, using your NumPy library, cos theta, cos phi, sin phi, every function is there. Okay, am I clear enough? Or still some confusion is there? Then please feel free to say me. Say the same. Okay. So this one was regarding your visualization. Okay. Then your key takeaways is there that XOR will use XOR example in which we have used the FFNN. Okay, okay, I think you are clear. It is fine. Okay. So now feed forward neural network. It uses XOR example for on a small data set. Then MNIST example demonstrates scalability to complex real world tasks. Then hidden layers plus nonlinear activation functions will make the feed-forward neural network capable of learning complex functions. In conclusion, feed-forward neural networks are the foundations of your deep learning. Okay, and they both solve simple and complex problems. And advanced networks like CNNs, okay, convolutional neural networks are very popular nowadays. Okay, all the YOLO models as well as all the computer vision models are nothing but CNNs, convolutional neural networks only. Okay, then recurrent neural networks are there, RNN and transformer models are also there. Okay, are built on those particular principles only of feed forward neural network. Okay, then real world example is there. Okay, a breast cancer Winkosen data set is there. Okay, you just try to search about it. Okay, why is it copying the entire line? I don't know. In Kaggle as well as in various open source platforms, okay, you can find out this particular data sets. Okay, this particular data set is there already that has been trained on various models, and you can find out what is the classification accuracy, the regression accuracy. Okay, all the accuracies you can try to find out. Okay, as well as how many approaches people have found out. Okay, so various models also have been developed. Okay, so this is these are the principal aspects over which we thrive upon. Okay, so our data set, if the goal here is to predict whether it is a malignant or benign, okay, which type of tumor it is. Okay, so data set is having 30 features, mean, standard error, worst values of cell nuclei, everything it is having. Okay, we just have to fit in the values and try to classify whether it's malignant or benign or it is 1 or 0. Okay, so here I have used from sklearn datasets import the load breast cancer. Okay, this particular class is there. Okay, they directly have incorporated this particular function inside Python. Okay, because a lot of people were using it. Okay, so similar type of data set they already have incorporated, so I don't have to download it from some link. Okay, as well as incorporate in my GitHub, in my Google Colab notebook. Directly, it has been there as an inbuilt function. Okay, so I'll use it from here onwards only. Okay, then you go for loading the data set. Then you try to split into test and training and testing data set. Okay, test size I have taken at 0.2, means 80-20 classification. 80% data for training, 20% is there for testing. Okay, from this particular data set only. Okay, and for validation I may use some real world data set which I would be able to obtain from any another data set which I have used for training and testing. Okay, then standardizing the features. Okay, using standard scalar, then fitting the transformation, then building the feed forward neural network. Same procedure I have used. Okay, so number of layers you can see here, the activation functions. Okay, then you are seeing here the optimizer and binary cross entropy and matrix as accuracy. Okay, then you try to fit the models. Okay, and batch size, this batch size means the number of images that would be taken in one set of the generation of an epoch. Okay, that is your batch size. Okay, so that particular batch size, if you try to increase from 16 to 64, then 128, your training will take more time. Okay, but your accuracy would be more higher, moving towards the higher side. Okay, so batch size and number of epochs are the general parameters which we try to play with firstly if we are not getting the results. Okay, if we don't get results, okay, which we want to achieve, then we go towards this, changing the entire neural network. It can be any neural network. Okay, it may be simple neural network, it may be complex neural network, but we just try to change the values and try to define our own neural network also. Okay, then test accuracy directly I have obtained is 96%, 96.5% I have directly obtained it. Okay, here you can see here. Then similar to the question example number 2, I have plotted the training and testing accuracy curves here. Okay, so accuracy you try to see here, training accuracy as well as the validation accuracy or the test accuracy I have plotted here. Okay. Now, what are the observations? 95%, more than 95% of the data set it is able to accurately classify. Okay, feed forward neural network. Hidden layers help the network to learn the complex relationships between features, and this shows how feed-forward neural network can be applied in healthcare AI tasks. Okay, if you are having any further suggestions, then feel free to ask, feel free to add. Okay, that how feed-forward neural network may be used in any of other tasks. Okay, so we just try to explore the feed-forward neural network application in XOR problem, then MNEST image classification, then breast cancer dataset or real world medical classification. Now you can use it from this particular concept to imbibe your basic theory into real AI applications. Okay, these these all the approaches are under the broad domain of AI, artificial intelligence. Okay, AI is the broader domain. Inside it, the domain narrows down to machine learning, and inside of that, there's a particular domain which is deep learning. Okay, the flow chart diagram. I'll just try to explain you AI, machine learning, and deep learning. Okay, this particular is the flow. Okay, artificial intelligence is in the outer domain. After that, it is machine learning. Inside it, machine learning, there are neural networks, and on the basis of neural networks, all the neural networks, a particular domain has been formulated, which is deep learning. Okay, so if you are doing some project and you are using machine learning or deep learning inside it, then you can label it as AI project. Okay, so this is what I was trying to explain you. Now, another example is your real world example is your regression using feed forward neural network on based Boston housing data set. Okay, this particular is one is also a very famous example, Boston housing data set. These all the data sets have been recently incorporated in Python. Okay, prior to 2 3 years, these data sets were not there, and so much of classification, regression, analysis was not being performed. Okay, Python was just being used for very simple tasks. Okay, and for solving some of the complex problems or maybe in programming domain it was being used. But nowadays it has been the usage has been extended further. Okay, to so many newer domains have been explored. Okay, this is what I wanted to say. So many newer domains have been currently being incorporated inside Python only. Okay, so this is there. Then you try to see from sklearn import dot data sets import fetch California housing. Then from sk learn dot model selection we import train test split, then standard scalar, then sequential, then layers. Inside it dancing is there. Okay. Then loading California housing data set is like this: housing equal to fetch California housing. Okay. Housing dot data is there, housing dot target is there. Okay, train test splitting is there in 80%. Okay, 80 and 20%. Then I have used the standard scalar. Then I have formulated built regression feed forward neural network. Okay, with number of layers you can see here 64, 32, and 1. And the transfer functions also you can see. Then I've used the Adam optimizer and the loss value. Now I haven't used the cross entropy loss. I have used mean squared error MSE, and metrics I have used mean absolute error MAE. Okay. Then I have tried to fit in the model. Okay. After that, I am evaluating the accuracy on mean absolute error. Okay. So mean absolute error I am getting is 0.36, which is very minimal, and I can directly claim that my neural network is sufficiently able to solve this particular problem. Okay. So training pros means squared error. You try to see here from 1.4 we have decreased it towards less than 0.2. Okay, it is coming less than 0.4, 0.3 somewhat. Okay, so training loss as well as validation loss you can see here. Okay, and final observations are fit for a neural network learns to predict houses with reasonable error. Okay, unlike classification, the output layer is having one neuron with linear activation, and loss function is MSE. We can also track MAE. You can directly plot MAE also here. Okay, aside of this plot, you can do this simple exercise. Try to plot down the MAE also. Okay. Then for four problems, XOR nonlinear classification, we have used this particular FFNN. Then for MNIST dataset, we have used image classification. Then for breast cancer dataset, we have, as a medical classification, we have used feed-forward neural network as well as for Boston-Hausen problem. We have used this real-world regression. Okay. So this marks the end of this particular session. Okay, in which I wanted to discuss this particular Google Colab notebook as well as the 10 questions which I have discussed with you. Both of the things have been already shared, okay, with you all guys. Okay, you can see here, see there what are the different things which I have just presented in front of you. Okay, try to at least run down this particular notebook. Okay, it would be very helpful for you because you all are must be computer science students and would be solving some of the very practical problems. Okay, those haven't been solved till yet. So basis is very important. Basics of anything in any domain is very important. That is why I wanted you all to please run these particular notebooks. Okay, try to see what are the different opportunities, what are the different critical aspects. Okay, where you can change the things, you can play with the parameters. Okay, and you can get the greater accuracy or lesser accuracy which I have got. Okay, so this is for you to explore, and please go through the 10 questions which I have solved. Okay, and this marks the end of the session. Okay, thank you all for joining. Do join the session next week, same time, same link. Okay, two more sessions would be there. After that, one session would be summary session in which I will be explaining you some of the concepts which would be very helpful for you to solve the questions which would be there presented in front of you in the examination. Okay. So yes, once again, thank you all. You can kindly leave. Okay. Otherwise, if you have any doubts, feel free to discuss. Okay. I am here for 10 more minutes. Okay. Thank you. Thank you all for joining.
Yeah, hi sir. I have a question.
Yes. Please go
So,
ahead.
in exam, there will be only MCQ and MSQ question, or other than also?
This particular pattern actually that is should be mentioned in the admit card. Okay. The exact pattern would be mentioned in the admit card. If you want to know what pattern exactly they are following, because year by year it is changing. Okay, sometimes it is a mix of both, sometimes it is only objective, sometimes it is only subjective also. No, never it has been only subjective. Okay, it has been mixed of both or only objective. Okay, so this thing you please try to clarify with the NPTEL team. Okay, you must be having the mail ID, otherwise I can provide to you. You try to write down a mail to them and they'll be telling you what would be the pattern, and it would be mentioned in the beforehand in the examination admit card also. Okay.
So
Understand.
I have a question.
Yes, please go ahead.
So how many more sessions are going to be there? Like,
Three more sessions would be there. Week number 11 would be there. Week number 12 would be there. After that, the very next day, there would be a summary session in which I
okay,
would be explaining you the concepts which I have covered from week number 1 to week number 12. Okay.
okay, okay. And are the topics going to be based on only classification and regression, or projective geometry and
See, the topics would be based on the offline, on the basis of the video lectures, okay, which
okay,
we release week wise. Okay.
okay,
And on the basis of those only, we have formulated some of the multiple choice questions based on previous year assignments that I'll be explaining to you. And then I'll be practically demonstrating. For example, in present session, a question was there regarding feed forward neural network. So so I try to explain you practically also. So this is
Okay.
how the flow would be. Okay.
Okay. Okay. Thank you.
Okay. Okay. Welcome.
And one thing I want to know that in exam there will be mentioned that after submit the form you have no option to change exam center. So
This
they
thing
actually
also you try to clarify with the NPTEL team. Okay. If you want to change the exam center right now,
uh,
no.
yeah right now.
No, no, no. That option is not there. Whatever you have filled, that only would be your examination center. This is true for all the examinations which are conducted in India, not only for this examination. Okay.
Yeah, I saw the disclaimer, but
Yeah.
uh, few reason I will be other cities. So that's why I just
Yes, yes. You have to plan and manage your travel and all those things accordingly. Okay. Because this facility is not there even in for any of the examination. Okay.
yeah.
Once the center is filled, then there is no option. But still, you can mail the NPTEL team. Okay. If they are in a position to help, they can help. Okay.
Okay, sure, sure. Thank you so much.
Ambu,
Oh,
just a second.
yes.
Okay. So the sessions that are going to be taking place are always going to be every Saturday from now.
Yeah, every Saturday from now. And if you haven't visited my previous sessions, I will be giving you the link also. I
Okay.
have already recorded the sessions, put them on YouTube. I'll be sharing the link for the PDFs also. You can follow that same link. Okay.
Okay. And it's going to be based on week 1 through week 12, right?
Yes,
Week
yes, yes.
11.
Yes, yes. Week 1 to week 12. Okay.
Okay.
Yes.
Okay.
Just 1 second. You can see this particular Google Docs spreadsheet. It is having every link. Okay. Even for recordings, for PDFs, as well as for Google Colab notebooks. All the information is shared in this particular uh, notebook. Okay. Okay. Thank you all for joining the session. Do join the session next week, same time, same link. Okay. And thank you so much. I'll be ending the session for you all guys. Okay. Thank you. Thank you everyone.